My name is Stephanie Frost and this is Mathematics in the Classroom. This presentation aims to use mathematical problem-solving skills to find a way of reducing my environmental footprint in the home. Specifically, this will involve the use of installing a rainwater tank. This problem is going to be developed and solved through the use of the mathematician George Pollier's four-stage model of problem solving, which includes beginning by understanding the problem at hand, followed by devising a plan for solving it, carrying out the plan, and lastly the looking back stage, Reese 2012. We will begin with the stage of understanding the problem. According to the Australian Government's Department of Health 2011, the use of rainwater tanks has become a major strategy to enhance water conservation, reduce the burden of water restrictions, and address the increasingly dramatic impacts of drought and climate change. The Australian Government offers a significant rebate on the installation of a rainwater tank under the Long-Term Water for the Future Plan and the associated National Rainwater and Grey Water Initiative. Continuing on from this is a mind map, and it's been created in order to clearly outline the possible avenues that need to be explored and addressed in order to help solve this mathematical problem. There are many considerations that need to be taken into account. Firstly, the contributing factors associated with how much water is being consumed. This can be identified through the use of an online water usage calculator and then displayed in a pie chart or table displaying how much water is being consumed by each family member on a weekly or quarterly basis. This includes drinking from the tap, showering, brushing teeth, and watering the garden or washing of cars. This can also be displayed through the use of a water bill that has been used before a water tank has been installed. Once this has been calculated, I can determine how much water is then used after the tank has been installed by locating percentage decreases of water saved associated with water tanks. I may also calculate the environmental footprint before and after a water tank has been installed and display these results on a line or a bar graph. I will also need to take into account the costs of installing and purchasing the tank and the mathematics that will be needed to complete this problem. This may include, but not be limited to, the use of volume, addition, subtraction, average, use of averages, and multiplication and division. Moving on now to the stage of devising a plan. This involves looking at the mathematical topics I feel will need to be drawn upon in order to help me to solve this mathematical problem. They are all associated with the Year 5 mathematics strands taken from the Australian Curriculum 2014. These include measurement and geometry, number and algebra, data representation and interpretation, and money and financial mathematics. Now that we have established the area of mathematics we will need to draw upon, we can look to where this maths is going to be required. Firstly, as shown on this slide, it can be seen that I have found the residential water charges that are used for the Hunter region in New South Wales. As displayed in the table, there is a yearly rate charge of $17.75 and then $2.22 is charged per kilolitre of water used. I will need to convert the kilolitres to litres as it is a unit of measurement more suitable to a Year 5 maths level. I will also need to divide the annual rates to monthly or quarterly as this is the time period I am calculating for. Moving on, this table demonstrates the results of water usage in my home, which is occupied by 5 people. After answering questions regarding where water was being used in the house and for how long, the Hunter Water website calculated my water usage over a 12-month period. As with the previous slide, these yearly calculations will need to be divided to allow for a quarterly rate and will be used to calculate money saved and water saved over a 4-month period. This pie chart displays these water usage results. As you can see, water was mainly used in the bathroom at 80%, and then lower amounts in the kitchen at 4%, the laundry at 5%, and on the lawns and gardens at 6%. This slide demonstrates the average savings of water that can be expected after a rainwater tank is installed, and will be used to calculate the before and after savings, both in terms of financial and environmental. Results showed that 50 kilolitres per household per year would be saved on average, or 34% of the water used in residential properties. These results were found on the Urban Water Security Allowance website, 2011. Now that we have devised a plan, we need to carry out the plan. Step 1 involves calculating the water usage before the rainwater tank existed. This can be done by the bathroom plus the kitchen plus the laundry plus the lawn and garden plus the car, which is bathroom 260 plus 12 at the kitchen, laundry 16, lawn and garden 19, and car 16, which ends up equaling 323 kilolitres per year. Step 2, we want to convert these yearly results that we have just obtained to quarterly results using long division. Water usage per year divided by the quarterly time period of 4 months. The water usage per year is 323 divided by 4 months. Upon doing the division, the children will find that it is 80 with a remainder of 0.75. They would be asked to round it up to 81 kilolitres per quarter. Step 3, we find out the cost of the water usage. To do this, we look at the annual base water service charge divided by the quarter of the year, which is 4 months. So the annual base water charge was $17.75 divided by 4, which equals $4. And then as you can see, they needed to round 2 decimal places to $4.45. The quarterly usage plus the kilolitre usage rate, which is 81 by $2.22, which equals $179.82. The base water service charge then plus the quarterly usage is $179.82 plus $4.45, equaling a total of $184.27 per quarter before the rainwater tank. Step 4, we look at the savings after the rainwater tank was installed, which is 50 kilolitres saved per year divided by the quarter of the year, which is 4. That equals 50 kilolitres divided by 4, which equals 12.5 kilolitres saved per quarter. Step 5, we looked at the kilolitres saved per quarter, which we do the kilolitres used per quarter before installation minus the kilolitres saved per quarter after the installation, which is 81 kilolitres minus 12.5. Therefore, 68.5 kilolitres is being used after the installation. Step 6, we calculate the money saved. The kilolitre water rates times the new kilolitre used after the installation plus the quarterly base rate fee. $2.22 by 68.5 kilolitres plus $4.45 equals $152.07 plus $4.45, which equals $156.52 with the new water charges. Therefore, the money saved equals the old charges minus the new charges, which is $184.27 minus $156.52. Therefore, there is $27.25 of money saved per quarter after the rainwater tank.